Good evening, everyone. I'm Brock. So today, the academic paper I want to review is called YOLOv10, Real-Time End-to-End Object Detection. And okay, let's start. So what is YOLOv10? YOLOv10 is a real-time end-to-end object detector that can quickly and accurately identify and locate objects in images without requiring additional post-processing steps. Imagine you are looking at a photo and your brain can instantly identify objects like person, car, dog, and know where they are in the photo. YOLOv10 is like an AI system that can mimic this human ability, but it's faster and more accurate than previous YOLO versions. Core functions: NMS-free end-to-end detection. What is NMS? Okay. NMS called non-maximum suppression. Traditional YOLO models generate many duplicate bounding boxes when detecting objects. For example, when detecting a cat, it might produce 10 bounding boxes around the cat. This requires NMS to remove duplicate and keep only the best one. However, NMS increase processing time and affects real-time performance. YOLOv10 uses dual label assignments strategy with two heads during training. One-to-many head used during training to provide rich supervision signals, like a student doing many practice problems. One-to-one head used during interface inference, outputting only one bounding box per object, eliminating the need for NMS. Supposing you are detecting a dog in an image. The workflow is input an image into YOLOv10 model. During training, you will generate multiple boxes. Okay, for one-to-many head, you will generate multiple boxes. For one-to-one head, it generates one box. And during inference, only use one-to-one head. Directionally output one box. No NMS needed. Function 2, efficiency accuracy, trade-off optimization. YOLOv10 comprehensively optimize the model architecture to significantly reduce computational costs while maintaining high accuracy. This is like optimizing a race car to run faster while ensuring safety performance. Specific optimization strategies. Lightweight, lightweight classification head, spatial-channel decoupled downsampling, rank-guided block design. I feel that I have no idea what this strategy is about. Function 3, enhanced model capacity, capability. YOLOv10 not only pursue efficiency, but also enhance the model's expressive power by introducing large-kernel convolution and partial self-attention mechanisms. Large-kernel convolution. PSA, partial self-attention. Actually, I have no idea what this terminology means. So for YOLOv10 input image, efficient detection, direct one box output, final results. But for traditional YOLO, input image detection, generate multiple boxes. And we need to do NMS post-processing to have the final results. Okay, core technologies. First one, consistent dual assignments. Imagine you are a teacher teaching students how to identify animals. One-to-many means giving students many practice problems. For dog image, you ask students to identify it from multiple angles and features. This way, students learn rich knowledge. One-to-one, like during an exam, you only ask students to give one best answer. This is more efficient and it doesn't require subsequent duplication work, deduplication work. YOLOv10's collaborative approach is to use one-to-many during training, which is rich learning, and use one-to-one during inference, which is efficient output. To achieve consistent matching metric, align the learning objects of the two heads. YOLOv10 propose a consistent matching matrix. For a lot of those tactical details, we must be good. We must be good at utilizing these mathematical equations to achieve those goals, such as here, right? To align these two heads, is actually use a formula to achieve this goal. But actually, I already forgot most of those maths. K-innovation. Okay. K-innovation is to make alpha O2O is equal to alpha O2M, and the beta O2O to equal to beta O2M. Ensures that the best sample selected by the one-to-one head aligns with the best sample from one-to-many heads, reducing the supervision gap. So So from ground truth object, the one-to-many assignment, then get multiple positive samples. One-to-one assignment, get one positive sample. Keep both for training, and only use the one positive sample for inference. Okay. The second one is lightweight classification head. Imagine you're ordering at a restaurant. Traditional classification head, like a complex menu with detailed descriptions, ingredients, and cooking methods for each dish. Rich in information, but slow to process. And a lightweight classification had like a simplified menu with only core information such as dish name, price, main ingredients. Faster with similar efficiency, effectiveness. And to achieve this goal, it needs to use depth-wise separable convolutions. So it need to use depth-wise convolution. It need to use point-wise convolution. Technique 3, spatial-channel decoupled downsampling. Imagine you are organizing a large bookshelf. Traditional method is to simultaneously reduce shelf levels and increasing book tabs per level. In one go, but easy to lose books. And decoupling method is first increase book tabs per level and then reduce levels. This better preserves information with less loss. So the technical process is input feature, increase channel, intermediate, spatial downsample, and output feature. Terminology 4, rank-gated block design. Imagine you are managing multiple departments in a company. Intrinsic rank is like a department's information density or efficiency. Low rank means redundancy, too many people for too little work. High rank means lean and efficient. So the optimization strategy is to use streamlined structure for low rank departments, which has high redundancy and maintain original structure for high-rank departments, which is high efficiency. And here are some technical details. YOLOv10 calculates intrinsic rank by analyzing singular values of each stage. Okay, I feel that I have no clue about how this calculation is achieved. Technique 5, PSA, partial self-attention. Imagine you are in a meeting. Full self-attention means everyone communicates with everyone else in the room. Information rich, but time consuming because 10 people need 100 communications. A partial self-attention means some people engage in a deep communication, others do simple exchanges. Efficient in similar efficiency only need around 25 deep communications. I almost forgot. I think I forgot what convolution means in math. Input feature, do convention. Part 1 is C2 channel, blocks multi-head self-attention. Feed-forward network. Part 2 is C2 channel, direct pass, concat, and do convention fusion, output feature. Confusing. Okay. Okay, now let's go to some AI or ML and ML terminologies and concepts. Object detection, OD. Object detection is a computer vision task that involves identifying and locating objects within an image or video by drawing bounding boxes around them and classifying their categories. Okay. Non-maximum suppression. NMS is a post-processing techniques used in object detection to eliminate duplicate bounding boxes for the same object by keeping only the box with the highest confidence score and suppressing overlapping boxes. 3, intersection over union, IOU. IOU is a metric that measures the overlap between two bounding boxes by calculating the ratio of their intersection area to their union area. It ranges from 0, which is no overlap, to 1, perfect overlap. FLOPs, floating point operations. FLOPs measures the computational complexity of a neural network by counting the number of floating point arithmetic operations required for one forward pass. Okay. Mm. So you see, if without computer, it's almost impossible for humans to do such a big calculation. So a lot of evolution it's not linear. It's actually like a jump, like a stage. You must achieve a specific prerequisites to go to next stage. Term 5, AP, average precession. AP is a metric that summarizes the precession recall curve by computing the average precession across all recall levels. It is a primary evaluation metric for object detection, measuring both localization accuracy and classification accuracy. Okay. Hmm. End-to-end. End-to-end refers to a system that processes input data directly to final output without requiring intermediate manual intervention or post-processing steps. In the context of YOLOv10, it means the model outputs final detection results without leading NMS. Of 7, convolutional neural network. A CNN is a type of deep, you know, I learned CNN, I guess, in undergraduate, but I fully forget what is, the details of it. I guess that maybe I actually don't really understand how it works at the very beginning. AN is a type of deep learning neural network specifically designed for processing grain-like data such as images. It uses convolutional layers to automatically learn spatial hierarchies of features through back propagation. Core components such as convolution layer, pooling layer, fully connected layer. Terms 8, self-attention mechanism. Self-attention is a mechanism that allows each position in a sequence to attend to all positions in the same sequence, enabling the model to capture long-range dependencies and global context. It computes attention weights by measuring similarity between query key and value representations. Hmm. Term 9, Depth-wise separable convolution. Depth-wise separable convolution is an efficient convolution operation that factorize a standard convolution into two separate operations. A depth convolution that applies a single filter per input channel, followed by a pointwise convolution that combines outputs across channels. You know, from an end user perspective, we see the applications improve every year, every month, or even every week. Fundamentally, it's because all those academic papers prove the efficiency improve. From a theoretical perspective, Term 10, feature pyramid network. FPN is a neural network architecture that builds multi-scale feature representations by combining low resolution, simultaneous strong features with high resolution. Semantically weak features through a top-down pathway and natural connections. No, I still have no idea what this is about. Okay, so system design and architecture. YOLOv10 adopts the classical three-stage object detection architecture: backbone, neck, and head. So input image, initial convolution layer, feature extraction, stage 1, stage 2, stage 3, stage 4. Neck, PAN structure, multi-scale fusion. Okay, P3, small objects. P4, medium objects, and P5, large objects. Final detection, boxes plus class and confidence. Pipeline. Input image. Multi-stage feature extraction. Multi-scale feature. In feature fusion. Fuse the features. Fuse the features. One-to-many. Objects to multiple samples. One-to-one object to one sample. Predictions. Backpropagation. Inference phase. Input images. Feature extraction. Multi-scale features. Feature fusion. Fuse the feature. One-to-one prediction. Final bounding boxes. Core module design. First one is CIB, compact inverted block. CIB is an efficient building block that uses depth convolution for spatial mixing and pointwise convolution for channel mixing, designed to reduce computational redundancy in deep stages. PSA, partial self-attention module. Multi-head self-attention. Multi-head self-attention splits input into multiple heads, each computing attention independently. Then concatenates the results. This is like brainstorming where different heads focus on different information. FFN, feed-forward network. Feed-forward network is a simple two-layer, fully connected network, typically contained an expansion layer, which is increasing dimension, and a compression layer, which is restoring dimension, with an activation function in between. Okay, and here's some model specification comparison. Okay. Milestone. Impact. Okay, all this is about impact. Although YOLOv10 was released relatively recently, it has already been applied in multiple domains such as smart security, autonomous driving, industrial inspection, retail analytics, agricultural technology. You know, if we look at the history, the time between theory to application is hugely shrinked, right? It used to maybe take decades to go from theory to an application which can really impact normal people's daily life. But nowadays, it can be just several months. It's insane. So the founder, the first author is called Wang Ao. Okay, School of Software, the Tsinghua University. Research focus, computer vision, object detection, efficient neural network design. That's cool. I heard that in AI area, there's a lot of Chinese play an important role. I think that I should say China. We are lucky because the accumulation we have done in the past. If we think about from 1918, in the past 30 to 40 years, we have the foundation for one or two generation, at least one or two generation people. Well, at least one generation is mature enough, to catch up in the most frontier of the industry. If we lose, imagine if we lose those 30 years accumulation, there's no way that in this round of AI, race, China can catch up. So yeah, so sometimes when big moment happened, if you don't have previous foundation as a basis, you just cannot play the game. Yeah, all this is about the impact. Insights. Insight one, end-to-end is a trend, but requires balancing training and inference. Insight two, efficiency optimization requires targeted treatment. Insight three, partial, in some cases, is bigger than full. Engineering practice insights. Well, I have a thoughts. Well, later. Well, maybe. Um, okay, so insight one is importance of module design. Insight two is don't optimize prematurely, but leave room for optimization. Implementation for future research. Research direction one, future optimization of small object detection. Research direction two, extension to video object detection. Research direction three, integration of multitask learning. Okay, here are some reference, like core academic papers, open source projects and code, commercial products and applications, YouTube channels. Okay, yeah, so let's try to search for this stuff. Ultralytics, AI guide. Computer vision engineer. Two minutes paper. Okay. Subscribed. Yeah, I think that when I look back, if I recap what I should do much better since I end college. One of the thing I should do but I didn't do is that I should pay attention, fully utilize those open, free resources, such as GitHub, YouTube videos, all those resources actually and the academic papers, all those things are free, open. It just needs my time and attention to consume them. I ignore them. That's a very big ignorance and mistakes, I should say. Okay, here's some blogs, dataset, tools, conclusion. YOLOv10 represents a significant advancement in real-time object detection, opening new possibilities for practical application through end-to-end design and efficiency, accuracy, balance optimization. With the development of edge computing and mobile AI, YOLOv10's efficient end-to-end characteristics will have broader application prospects. We look forward to seeing more innovative applications and research based on YOLOv10. Yeah, cool. Yeah, that's pretty much for this paper. Again, still, I guess that there's still a lot of technical details I don't understand and the mathematical formulas. But I get some sense about what this work is about, what's the goal, what is the meaning, and what's the rough, high level rough workflow to achieve this goal. Yeah, I think that's pretty much about it. Thank you, everyone. Bye.